So chapter 8 is dealing with negative numbers and integers. We'll start in section 8.1. Which is just introducing the negative numbers. Okay, so the goal in this chapter is to understand why these things are true. Now, negative numbers is not a concept that you'd be teaching in the primary grades, but one thing to remember, if you are certified to teach in an elementary school, your certificate does not say you can teach kindergarten or you can teach third grade. Your certificate will say K6. So you might actually end up doing some of this stuff if you end up in some of the higher grades. And two, the more you understand, the easier it is to make sense of the more fundamental stuff. Okay, so our goal is to understand why these rules about working with negative numbers are true. Why is it true that a negative times a negative has to be a positive? Why is it true that subtracting a negative would be the same as adding the opposite? Okay, so let's talk about some models that we can use for working with negative numbers. So the key ideas are the models that we use for working with negative numbers. We'll have a chip model for signed numbers that is a little bit different than the chip model that we used for demonstrating the various algorithms for addition and subtraction and multiplication. If you remember that, we had different trays for the various place values. This is a slightly different chip model. Okay, we'll also talk about the number line model. And another nice model is a money model. Okay. When we introduce signed numbers, we also introduce a new operation that we can do. When we talk about arithmetic in the primary grades, there are normally 4 operations we can do with numbers. Add, subtract, multiply, and divide, okay? And all those operations involve 2 numbers. I can't just give you, say, 3 plus. 3 plus what? You've got to have a second number to work with. So those are operations that require 2 inputs. Once you get to signed numbers, there's a new operation that you can do that only requires 1 input. And that new operation is take the opposite. So if I start here at 2, and I take the opposite, it gets me to -2. If I start here at, let's say, -3, and I take the opposite, it gets me to +3. Okay. So let's keep track of some rules here for dealing with negative numbers. Okay, so the operation of taking the opposite is something that undoes itself. If you do that twice, you're back to where you started. If you're at +2 and you take the opposite, you're at -2. If you take the opposite again, you go back over here. Right, and that's all this says, right here. If you take the opposite and then take the opposite again, you're back to where you started. Okay, it's actually very useful for modeling things, right? Hit the switch again, back to where we started. Okay, there's tons of situations in real life where doing it twice undoes it. Okay, so we got to take the opposite as a neat little operation in mathematics to do that. Okay. And the number line model, hopefully pretty easy to understand. If we're talking about the positives, those are represented as the right side of 0. If we're talking about the negatives, those are represented on the left side of 0. So -4 is talking about a position on the number line, 4 units to the left of 0. Talk a little bit about this chip model, something I kind of like. Okay. So in this model, if I have a chip represented as a circle on my page, a chip that's filled in, that's going to be positive. A chip that's empty, that's going to represent a negative. Let's do some examples here. So I'm going to write down a couple chip models then I ask you what number is being represented. Okay, so the first two shouldn't be so bad, provided we keep straight what the filled-in chips and the empty chips represent. Okay, it kind of makes sense to me that the filled-in is positive. Filled-in, you got something in the middle. Negative, you don't have anything in the middle. You've got less than what you have in the filled-in chip. At least that's the way I make sense of it. Okay, so what number do I have here? 3, okay. Ordinary 3 or positive 3, whichever the way you want to write that. Now how about this? Negative 5. Okay, so that's the opposite of 5. Now, this isn't too helpful for your notes, but we have manipulatives that can be used to demonstrate this stuff. We have chips that have 2 colors. Okay, they're called 2-color counters. You can get a whole bag of them from EPA. That's the educational supply people. Okay, so you could have kids doing stuff with this by the operation of take the opposite is flip all your chips over. Right, you know that game Othello that has the 2 colors, and the game is to, like, if you put your chips on the end, then you get to flip over all the person's chips. Okay, chips that look like that. Okay, this is a little tricky. I haven't told you what to do if you have both kinds. You can probably guess. What do you think? Right, that would be 1. So if we have a positive and a negative, those kind of undo each other. And we have to look at what's kind of left over. So that's a 1. How about this?
Is that a 1 also?
Also a 1. Now, if you're talking about a number line, we could represent these on a number line by a positive chip is a step that way to the right, and a negative chip is a step that way. So we could imagine starting at 0, and we take 1, 2, 3 steps this way, and then 1, 2 steps back. So that's equivalent to taking 1 step to the right. In fact, there's a bunch of different representations of 1. You could represent 1 in any way that you like. That'll be important later on for doing some of the operations with the chip model. Okay, there's a bunch of different ways to represent 1, or any other number, for that matter. What's this one? Negative 3, right? These guys cancel. And you're just left with those over there. Okay. So let's do some operations and see how we can use the models to help us make sense of the operations. Okay, operation of addition, not hard at all, really, to do either way. Okay, let's look at case 1 here, positive plus positive. Let's do something like 3 plus 4. If I wanted to model this, I would start with that, and then I would add, in other words, I would put on 4 more positive chips. essentially the set model that we worked with way back in chapter 1, okay, where we would have collections of objects. And the operation of addition is just form one big collection out of the smaller collections here. Okay, so positive plus positive, easy to understand. In fact, basically the operation of addition with the chip model, really easy. If you did positive plus negative, well, let's do something like that. Let's do 3 plus negative 4. We start with 3 filled in chips. 1, 2, 3, 4. Oh, I guess I should actually write the answer here. Of course, we can see in the model that we end up with 7 chips if we start with 3 and throw in an additional 4. Okay, now here, this is what I would start with. And then into the mix I bring in 4 negative chips. So that means I have negative 1 chip. Okay, the other models are also not too bad. So if I'm using the number line model and I want to add negative 4, well, the 3, that tells me where to start. And then I'm going to move either to the left or to the right. Okay, if I was using positive plus positive, I start at 3 and I move 4 to the right. If I'm adding negative 4, I move 1, 2, 3, 4 units to the left. Okay, the direction is of course important when we're working with these signed numbers. Positive, we move that way to the right. Negative, we move that way to the left. So then we go over here. And either way, we're getting at negative 1. There's your answer. I also, in the key ideas section, I put up 3 models. I didn't have just 2. What was the third model again?
Money.
Money and IOUs. Okay, very similar to the chip model. Your positives, think of them as dollar bills. Okay, so this is $3, and then you have an additional $4, your total is $7. Your negatives, think of those negatives as IOUs. It's not a dollar that you have, it's a dollar that you owe somebody. So if I have $3, but I owe somebody else $4, I really have negative $1. The next dollar I get, I'm going to have to just give away to somebody. Okay, so, but very similar to the chip model, like these guys canceling each other out. If you have $1 and you owe somebody $1, you really got nothing. It's like if you have these 3 and then these 3, those cancel each other out, leaving you with the 1 negative left over there. Okay. So this idea with the chip model will basically work with any combination of negatives and positives. Okay, if you have a negative plus a negative, start with that number of negative chips, throw in the second number of negative chips, total them out, there's your answer. Okay, the fun thing, the nice part, comes up when we start dealing with subtraction. So let's do something like this. Positive minus positive. This first thing tells you what to start with. This second thing tells you what to take away. fact, this model will work almost equally well whether we've got positive, take away positive, or whatever. It's a free-for-all. But here's a fun thing. So give me some examples here, or let me give you some examples. Let's start with this. 5 take away 2. Okay, so positive, take away a positive. So very easy, 1, 2, 3, 4, 5. I'm starting with this. I take away that. There's my answer. Now, I could also throw in something like this. 3 take away 4. Okay, so start with 3 chips. Take away 4 chips. Take away 4 positive chips. So start with 3 positive chips. We're thinking take away 4. You might say, well, all right, 3 positive chips. I can't take away 4 because I don't have 4. However, remember what we talked about when we were looking at ways to represent numbers. This isn't the only way to represent 3. Give me an alternative way to represent 3. In particular, an alternative that would allow me to take away 4 chips, 4 positive chips. Remember, you got a lot of choices as to how you're going to represent numbers. Look at all those examples. We only did 2, but hopefully from those you can get the idea of different ways to represent the number 1. So represent 3 in a different way. What could we do? Any ideas? Folks in Zoom land, any way we could have 3 in such a way that we could take away 4? Go ahead.
Could we
Use measurement models.
and do minus, like -4 plus 3?
Okay, we could do that. So switch these to negatives, you mean?
Yeah.
Okay. I'd really like to be able to take away, to think of subtraction as take away. So we'll put a pin in that, we might come back to it. Somebody in Zoom land had something?
We can use measurement model.
Okay, we could use measurement model, that's true. There's still a way to do it with the chip model. Okay,
Do -6, but then the 3 would cancel out, but I don't know how you would get.
okay, right, so that now we're getting closer to the idea that we need here.
I got 6 positives, 3 negatives.
How about this? What number is being represented on the board there?
-3.
Really?
3. Just 3.
Right, just 3. Remember, if you have 1 positive and 1 negative, they cancel. Okay? So one way to represent 3 is with 3 positive chips. Another way to represent 3 is with 4 positives and 1 negative. So why does this help? Right, now we can take away 4 because there's an alternative way to represent the number 3. So, this is what we start with. We take away those, and what we're left with, that's our answer. So 3, take away 4, -1. Now on the number line model, the minus would be represented by taking steps to the left. Okay? All right, now how about something like this? Okay, 1 minute, we'll do one more example. What if I had, let's say, 2 take away -3? So this means I should take away that many negative chips. So is this a useful way to represent 2 as my starting point? Not really, because it doesn't allow me to take away any negative chips because it doesn't have any negative chips. So what should I do? Remember what we did over here. The whole reason we chose this model is because it had 4, and we needed to take away 4 positives. So what could I do?
Do the same thing.
Okay, very similar trick. We'll do the same thing. We'll throw in positives and negatives. Maybe I'll stack them on top of each other like this. Is this going to work? What do I have to do? I have to take away 3 negative chips. I have to take away 3 things that look like this. Can I do that right now? No. So what should I do? Go ahead.
You could do 5 positive and 3 negative.
Right, 5 positives and 3 negatives. Okay, so we keep on adding these pairs that cancel each other out. But the whole point of doing that is now, with that representation, I can take away those 3 negative chips. So what am I left with? 2 take away -3 is 5, right? You can see that 1, 2, 3, 4, 5 positive chips. Okay, so this chip model has different ways to represent the various numbers. And that's important because we use those representations to do the operations that we need to do. If you want to do 2 take away -3, you got to represent 2 in such a way that there are 3 negative chips to take away. So, I want you to get started reading through Chapter 8, Section 1 of Elementary Math for Teachers. That goes from page 185 to page 190. And on page 190, I would like you to do 1 through 4, do number 6, and do number 7. On number 1, don't worry about the vector model. Don't do that. Just do the number line model and the chip model. Okay, so 1 through 4, number 6, number 7. For number 1, what are we doing again?
Don't do the.
Right, no vector model, do the number line, do the chip model.